Oh, thanks. Let's start with our panel discussion. The moderator for the panel is William Bartholomew. He's working at GitHub. And in our panel we have Jeff McCaffer, GitHub again. We have Mirko Böhm from Indocode, and we have Diomidis Spinellis from the Athens University of Economics and Business. And William, I will give the microphone to you. You have the microphone ready. Yeah.
Okay, thank you. So the purpose of this panel is really to just discuss some of the major issues affecting package managers. We'll have time to take questions from the audience as well, and so everyone will get an opportunity, well, not everyone, but a group of people will get an opportunity to ask our panelists some questions as we go along. But I thought I would start off with everyone's favorite topic, which is naming and versioning. So major and minor versioning has been used for decades as a way of communicating breaking changes to consumers, and this has been kind of codified through SEMVer, which has become de facto in a number of package managers. There's an increasing belief that SEMVer isn't meeting the needs of the community and that it's lulling people into a false sense of security. And we'd be better off just doing chronological versioning. And so, who would like to have a comment on this?
So yeah, we did SEMVer for a long time. I used to be in the Eclipse community for quite a while, and we had quite rigorous semantic versioning practices, I'll say. And we often failed. It's hard because one person's notion of an API, we have to be very, very clear about what an API is. But I'm in favor of keeping and pushing down the path, even in the face of some failures, because it is an indication. An API is a contract between you, the producer, and the others as the consumers, and some level of communication as to my intent. I'm intending that this not break the API. I'm intending this be an incremental change, etc. Communicates to you as the consumer. I might be wrong, in which case that's like a bug, and you can report that bug and submit a pull request and all that sort of stuff. But without that, we're just kind of, hey, this is Thursday's build. Take it. Maybe it's good. Who knows, right? So that's my thought.
So I can say I'm typically a technology optimist, pathological optimist. But when it comes to versioning systems, it feels to me that we're always trying to add semantic information to something that's completely arbitrary. And therefore, I'm actually in favor of something like chronological release, because you basically communicate what version you're looking at without adding the artificial semantic information. But in the end, what works, so let's stay pragmatic.
I'm in favor. It's a coarse mechanism. We would perhaps want to have interface versioning at the level of specific API endpoints, but it's something that is, the other thing would be too complicated, but it could be better complemented by having things like long-term support versions, so that people know that they can pick up a specific version and have it supported for a longer time, and better communication of end-of-life policies.
Add a comment on that. One thing that we did to help support that as producers, having tools that tell you when your APIs change. Like, we have much better technology these days for analyzing your code and telling you when a change you're making now might affect your API. So we implemented tools a long time ago that would say, like, literally as you typed and you entered you had an interface and you added a new, an interface that was supposed to be implemented by consumers, and you added a new function, right, that would tell you, hey, you're changing the API, you're gonna have to bump your version number appropriately. And that's stuff that we can do. It seems to have fallen by the wayside. At least I've not seen a lot of it, but it's certainly there to help.
Yeah, I think the closest I've seen to that is there's a number of tools that will take commit messages that have additional metadata in them, such as, this is a breaking change, where it's taking the developer's intent, not quite as automated, but again, better than nothing. So kind of moving to the naming side a little bit, there's kind of two big problems in package naming. Well, at least two. The third is coming up with a name. But one of those is there's an increasing amount of typo squatting where people with malicious intents are creating purely malicious packages that have names close to the original. And then a similar threat is because people will often consume packages from multiple feeds, we have no guarantee that, you know, package foo version 1 on your internal feed is the same as package foo version 1 on a public feed. And so there can be opportunities for people to hijack the package that you're intending to use. What are your thoughts about how consumers and package managers can help protect against these cases and help protect the community?
I say a careful thing because this actually goes back to something that I ran into myself and was accidentally accidentally swapping letters and names and referring to a different package, and everything broke. And it was so hard to find because you look at everything and it looks totally sensible. And yeah, and here we found it. I think this goes back to this idea of you're adding artificial information on top of what you're versioning in the code. In a sense, every versioning of code that gives it an arbitrary name adds a layer on top of the actual repository. And depending on the languages you use, my favorite solution is actually to refer to submodules in this case, and to actually have a SHA-1 to point to the code I'm using. Then you don't have that problem. But that means by bypassing package management. So it's a conundrum.
One thing that can help here is basic hygiene principles. So let's be conservative in what we consume and what feeds we accept. If I go and invite 10,000 people to my home, something bad will happen. If I'm more conservative in the modules that I use and the transitive dependencies, that is going to be better. Regarding the accidental changes, some basic signature of the packages, which will not work when the same package appears with the same name appears in a different feed, should be enough.
So one interesting thing is that I think a lot of these things are endemic to ecosystems. And so package management people, like the folks who actually create the package management systems, bear a lot of responsibility for the things that happen in their communities. And so I think a lot of the tooling, the package managers, should be written and with these sorts of problems in mind. And I'll just one example, I won't name which community this is, but there exists out there today a package management system where if you have multiple feeds enumerated, it non-deterministically picks which feed it's going to pull the package. It basically sprays requests for the package versions and takes the first answer back. Right now, I mean, we laugh. There are reasons. There are reasons for that, but it does lead to actual problems where, like, my feed has the package and I'm happily using it, and then somebody magically creates a package with the same name. It's not typo squatting. They actually create a different package with the same name in a different repo, and suddenly, due to non-determinism, a hiccup in the network or whatever, I'm suddenly getting this other thing from outside.
But only every fifth time.
But only every fifth time, yeah, exactly. So I think that the package management infrastructure folks also need to be designing for these sorts of situations. I love the idea of like some level of signatures, whether it's like just a hash that's keeping track of this version is this thing, or actual signatures with like trust chains and so forth. I think can do a lot to help.
Yeah, so building on that idea of trust chains, one solution or way of addressing this problem is kind of using things like package popularity and the health of the package and that kind of metadata to give you a hint if you're going the wrong direction. What do you think about that as a way of helping consumers decide or realize that they may have made a mistake?
I think it's a good idea. The more data you have as a consumer, you can make more informed decisions. Being told when there's an anomaly, Suddenly you're taking a dependency on a package that's not as popular as you thought as it was previously. Like, you ran a resolution and all the popularity scores were above 50. I'm making arbitrary numbers. And suddenly you ran a resolution again and there's something that crops up that was like 20, much lower on the scale. That can be a thing. And also as you're actually picking things, picking packages that are known to be more useful. There's a danger in that it's like the herd mentality, right? Where people only use things that are popular, so anything that's new doesn't get any daylight. So that's a challenge. But
I'm a bit skeptical. That needs to be done very carefully. It's a good idea. If you get too many messages, people will just ignore them. If you raise the bar too high, then maybe you will not get warned when something bad happens. Just needs to be done very carefully.
I think we also need to look at the scenarios where you would apply such a process, right? So when you choose a dependency for a certain piece of functionality that you would like to import into your project, what I usually do is I do look at, for example, community health, like number of contributors, number of commits in the repository, ranking, things like that. But this is kind of a one-time choice you make. At a later point in time, when this is about managing dependencies in an ongoing process, looking at popularity, it's not the kind of diligence I would expect there, right? Because at this point, nothing beats diligence, which means people with eyes on your configuration and sorting this out. But maybe we're mixing these perspectives of like choosing what you use and then later integrating it into like build processes, etc.
Just a quick thing to add, you reminded me of something. One of the most popular markdown processors on Node for you, like if you went and looked at popularity, it was stale. It hadn't had any commits for like a year or something like that. And so people would go, and if you just followed popularity, you'd go and use Mark D, I think it was, and they'd go and use that thing, but it was like known to be stale, known to have problems. And finally, somebody went and put a thing on the GitHub page, saying, "Don't use this. It's old and stale," right? And so, just following the numbers doesn't answer the problem always.
Yeah, and specifically in that case, someone had created a fork, which, obviously would have started off with low popularity, which means, people may not have been selecting it, and that's why they were selecting the other to begin with. So kind of moving on to kind of how people express their dependencies that they want to consume. A number of package managers have a concept of lock files, and they're intended as a way to allow you to pin which versions you're consuming, often for both direct and indirect dependencies. Can these be fully trusted, and are they a substitute for a software bill of materials or other form of inventory?
I guess they can be trusted if the tools are doing what they say they're doing. There's two kinds of lock files in my view. There's the input lock file that's essentially giving advice to the resolver and saying like, hey, if you need foo, pick version 1.3.9. Then there's the output lock files that are said, this is what I did. I'm the resolver and I actually picked foo version 1.3.9 and it's actually in the configuration. I think we sometimes mix those two and treat them as the same thing. I'm much more interested as a developer in the input one, and as a compliance sort of person who's trying to manage large software systems, I'm much more interested in the output one because I want to know what the resolver did, not just what what people thought it should do. And the latter is not, well, actually neither are universally available, and I'd love to see them be available in all systems.
We asked, can these systems be trusted? Of course, not. I mean, no system can be trusted. They serve a purpose. And for the outgoing definition, they serve the purpose that whenever you build your software, you deploy your application, you're using a version that you know. But it actually puts another onus on you, because that means you're pinning the version. And you will find that in many real-life projects, the idea of saying version that or newer is actually not popular with the people deploying the applications because they're pulling in bugs with every new build. But that puts the onus back on the team managing the deployment to make sure that they then stay up to date with updates. So it's you're kind of blocking the process of automatic updates for a purpose, and that puts work and responsibility on you to stay on it. So I don't think the question can be answered in this way. And it in no way it replaces things like bills of material, which have a questionable usefulness anyway. It just serves a different purpose. It's apples and pears. Oh, that's the German version. Apples and oranges, I think.
Pinning is risk, especially when there are security updates. So that's one problem, and that's why I'm skeptical about them. They have a very nice advantage in that the producer of this component can scan and see which versions are used and what breaking changes might be introduced and how many will be affected. This is something that might be useful.
There's a question.
I mean, there's a whole bunch of opposing goals in resolving this lock files, right? Like you've heard security and features, right? And then there's also performance. There's more that you could do in the resolution mechanism, right? Like so right now you've got I usually call it a manifest for the input and then a lock file for the output. You could take a manifest and a lock file and you could try to produce a new lock file that's as close to the original as you can get for a new environment, right? Like the solvers can do that. It's not something that I think anyone's written, but you could actually say these projects need critical security updates, but don't update anything else because I know that configuration works. I think there's a lot more information you can put into that process to tell the solver why to prefer one version or another.
Right.
That doesn't get put into any of the tools today. They're all pretty simple in that regard.
So that was kind of my point about the differentiation between the input lock file. Like I actually think there are three things. There's the manifest, what did the developer think that they wanted, the developer of this component wanted. Then there's the consumer of the component that's taking this component and putting it in their system. And they're saying, that's all cool, you want foo version 1.3 or greater, but I want 1.3.9. That's what you're gonna use. And then, or maybe you give it a more constrained range. And then there's what the resolver actually did, and that's an output. Maybe we wouldn't call that a lock file, maybe it's more of a dump file or something like that. Anyway, there's Brian.
I just also want to say that the Sneak recently wrote an article about lock files and how you can actually insert packages that the resolver didn't resolve to, and then a lot of package managers or clients tend to just take whatever is in the
Right.
lock file, consume that. I think actually they could do a resolution that figures out I would have never created a lock file this way, and if clients did do that at CI time, you could actually avoid a lot of this problem.
Yep.
Most of them don't. Most of them just take a look at whatever the resolution file is and then create, like, generate builds based on that.
Yeah.
So does anyone think that lock files are inherently bad and should not be used? I'm guessing no, based. Anyone?
I think the question is rather, what else would you use? We can say it's bad, but do we have a better idea? There you go.
On breaking changes, you change the name. The name is there to give you a backward compatible future
It
whatever.
just moves the semantic information from the version number to the name.
I mean, it's identity, where identity is name plus version, and you just moves the version over into the name part.
Yes, that's true technically, but psychologically for humans, it's
I would be psychologically annoyed.
that's the point.
Is that a feature or a bug?
I consider it.
So
Yeah, so let's what else can we do? If we don't use log files for versions, so my perspective is primarily that of a software engineer, and I only get into package management at the end of the work. I use log files. I pin the dependencies of my builds so that I know which version I use, and I use a commit to change the versions I use to trigger a build and see worked before, not works. Okay, now we can use this version. So that's a certain purpose that this serves for me. And of course, we can say that's inherently bad. You can say it's bad practice. I don't know, better practice for what I'm trying to do there. So I really like to put the question to the room. Do we have a better way to do that? There seems to be a better way.
Well, so I guess since people are looking at me, The log file right now is just, it's a file that contains some versions, right?
Yeah.
It doesn't say why it contains those versions. Right. And so like, if you what's typically assumed is that that's what the developer tested with, right? Like that's sort of your best case log file, is that that's what the developer tested with. But, you know, in our world, like we probably have several different log files for different projects because we're building on different machines, right? Like, and so, you know, it even gets combinatorial at that level. And so, you know, what I would much rather have than a log file is, you know, like, why is the developer special? I would like to know that someone tested with these versions, right? Like, so I could have the log file from all my users for all the versions that they got working. I could have the log file for all the, I don't know, deployers or distro managers or anyone who ever tested the package, right? And report that somewhere. And then at least you have a better way of assessing, you know, confidence in whether the package is going to work for some criteria. But I mean, you probably need to go further than that and assign more meaning to it. Like they ran the full test suite, they smoke tested it, it compiled. Like, you know, there are lots of different things that particular configuration could mean. And I think, you know, you need more meaning.
So a friend of that's something that happens in GitHub. There's this feature called Dependabot. Well, it's now called automated security updates. But what it does is that when it sees there's a vulnerability in one of your dependencies, it tries to propose a PR that's going to update that. And one of the things they do is look at all of the other things that, all the other uses of that component that they're updating to, and they run it, and the tests have run, and see if the tests pass. And they sort of try to develop a compatibility score. Now, it's by no means perfect. That's not, but the reason I bring it up is it's kind of down this path of crowdsourcing the notion of things working together. Right? We've got all of these millions of people, or depending on how big your ecosystem is, lots of people using these packages. We can actually tell whether or not, by actual like experience, whether or not version 1.3 is compatible with version 1.4.
I was going to add one more thing about the log files, just that they're not human reviewable. Like most log files, like any generated file, humans are terrible at actually reviewing these. But you can tell Git with like Git attributes or something like that. Like here is a program that can do the diffing of this file. And so if clients were able to actually do an improved human review of a log file, you could set up a system so that Git actually does a diff in a human like reviewable way, or maybe just give a plus or minus, like this is a correct log file for the diff.
One other thing is we can be more careful in breaking changes, so we can consider breaking changes to be an unsocial activity. And we see things like the Unix system calls that have worked for decades with small changes, and their names have been changed. So we have wait and wait 2 and wait 3 and wait 4 because their changes were needed. But read, for example, has stayed the same for 50 years.
I'd like to respond to the statement that log file changes aren't human reviewable. It really depends. It's a matter of engineering practice, I think, more than tools. So I usually ask that if there is a change to that, it's a separate change. Like the configuration change is like one PR, which means the only change you have is in the log file, which is either plain text or JSON. And I think you can review it. It's work. But I mean, if you review a sizable PR, it's also work. So it can be done. The question is really, is it the right tool for the job? And there, with thing you said, I think one thing we do lump together is that we kind of think of it as like a one size fits all. There's this one log file in there. It says these are the dependencies, basically. But if you take that code and you deploy it into different places, then that's the wrong tool for the job, because then you need configurations for the different deployments that you're making. We usually use vendoring repositories for that, where the configuration is in the deployment, and then you pull in the code that you're using for that. And we don't use the setup, the dependencies for the generic configuration. But that's just, basically it's a workaround for different deployments.
So I want to go to the other end of the spectrum. So log files give us a lot of predictability and pin things in place, but a number of package managers express their dependence or their manifests as executable code. And and you know that has the power of being able to be dynamic, but with that comes certain challenges. Can Can you talk about these challenges and the problems they cause for consumers? or is it just, no, don't do that?
So, I mean, okay, it's cool. You can do it. Not everything you can do, you should do. But that's fine. If you're doing it, at least if you do that in your ecosystem, provide a mechanism for dumping what the resolver did. Because the challenge with all these systems, and this is a problem we have in GitHub with things like Dependabot, is that if you've got running arbitrary code, the only way you can understand what the resolver is going to do, what dependencies you're going to get, is by running the code. But if it's arbitrary code, well, then it's not trusted. So now I have to figure out how to run your code in a trusted or untrusted environment in a sandbox, so I can even figure out what set of dependencies you're going to have. Now, if you ended up at the very least, with a lock file or a dump file, I would be able to understand more about what the system is doing and then be able to reason over it. The reason why declarative stuff is useful and powerful is because it's declarative. I can simply reason over the face value of what's there, as opposed to having running arbitrary code. That's all I had to say.
No, I just want to say one thing. Nobody wants that. So, for more than 2 decades now, the idea of using a Turing-complete programming language to do configuration management comes up again and again. And none of the systems that came up have reached dominance in the market. I think there may be a reason for that, and that is engineering is already complicated, like software engineering. And if you add another layer to it to make it like exponentially more complicated, maybe that's just not the right way. And I think the systems that are successful typically are almost simple to the extreme, right? They use a plain text file to tell you what the dependencies are. Maybe they use a little setup file to install the package, but it's like 10 lines and you can read it, and if you know the technology. Yeah, so maybe simplicity is key, and that's why this doesn't get adopted. It's working, but it doesn't get adopted.
So I want to move on and talk about the topic of reproducibility from a couple of different aspects. So one is there seems to be a mix, and I'll actually pose this question to the audience. How many people work in environments where you rebuild packages from source rather than consuming binary packages? I'd say roughly 50%, which is, so the same question was asked in the legal dev room earlier today, and it was roughly 50% there as well. This poses a number of challenges. There's some difficulties to it, and it can cause problems. What do you think? So firstly, what's your opinion as to whether this is a best practice? And if so, what are some things that the industry can do to make this easier and better?
It should certainly be an option of any packaging system to offer this ability. We heard good reasons why this can help with the performance, for example, certainly for security, for compliance, and this is why I believe it should be available. Whether people prefer to use it or not, that is something that should be left as an option.
We used to say, don't take binaries from strangers, right? So, well, the question is, who is a stranger? A lot of this is about trust. We have a lot of discussions like this where we seem to think that technical solutions can replace trust. Imagine you have a completely trustworthy source. Say GitHub is running a build service, and it's completely transparent. You can introspect everything, and they're producing binary versions of packages and offering them in a repository. And you can completely assess how they're doing this. And we assume that it's completely trustworthy. Would it really be useful to compile on your own all the time? Think of the trees, right? Think of how much electricity we're wasting and time as well. So
HPC guy.
there you go. Yeah. What do I care about the?
Why we compile from source, we're thinking about the
Yeah. What do I care about the megawatts we're using, right? So in the end, there's time for it. So I come from a background of being a C++ developer. Of course, we build everything from source code every time, but really, But that's the question. That's the matter of trust and of good technology, right? So VC package solved a lot of these issues for compiled languages, where binary versions weren't used at all, not accepted. I don't trust binaries from strangers, and all of a sudden people said, "Well, this is good, you can use it." So I think it's an aspect of getting into the more modern world and saving the environment. And you disagree with me?
No, I don't.
So it's interesting. It's long been observed that there are two camps. There's those who won't use it if they didn't build it, and those who don't use it if they did build it, right? And there's no right or wrong. I mean, the interesting thing about building it yourself, if you have a really rigorous, my ideal is that there's a really rigorous, reproducible build system that can be strongly trusted. So I can get it, I can push build, and it's real understood what build means. It's not like some massive long command line argument that I can get wrong. I can just run the build, and it runs, and there are no warnings, there are no errors. It just builds and says, good.
It did nothing.
But if there are, well, but like, imagine this. Imagine this, you're a typical open source consumer developer person, and you're using, hundreds of components, and you're trying to build them all, and you've typed make or whatever your build system is, and all this spew of orange and red goes by on your terminal. Like, are you going to trust what you just built? Are you going to ship that to your users or your customers? No. If it comes up all green, I might start having warm fuzzies. But if there's anything non-green on there, I'm not shipping that. I'm immediately now have to spend hours digging through other people's builds trying to figure out what's going on. So that build system needs to be trustable. Like, it's a two-way street here, right? I have to be able to trust the reproducibility of it. I would love that were true. But we're not even at the point. Just to set the context here, I mentioned this maybe in an earlier talk. 42% of the packages, we did a little survey of about 200,000 packages. 42% of them don't have any reasonable way of going from the binary version, like foo version 1.3, to the git commit. So that means you can't identify, even, let alone build. You can't even identify the source for 42% of the packages. Sorry? Oh, that was across a bunch of ecosystems. Yeah, it's not meant to be like the broad brush generalized, but I'm talking like there are over 200,000 across a bunch of different ecosystems. That's the kind of statistic that you hit. So whether it's 30% or 70%, it doesn't matter. It's not 2%, right?
Just to take devil's advocate, okay, you might not trust the binary, but what makes you trust the source? You can look at every line of source.
It's a good point. I mean,
Yeah.
I guess I don't disagree with the people who said that they prefer binary packaging. It's just that the reason that we don't use binary packaging is because it doesn't work for us, right? Like, and in fact, like Stack itself it's a build from source package manager, but we do binary caches, right? Like Nix or Geeks or some of these other systems. And we're trying right now to provide enough provenance with the binary to understand where we can use it, right? The reason that people don't distribute optimized binaries is because there isn't a good naming scheme for microarchitectures and things like this. I'll come to my talk tomorrow for that. But if you can provide a binary and provide sufficient provenance with it that it will satisfy the user, then you can totally distribute binaries everywhere. Right? And if you can make them trustworthy, right? If you can sign them or whatever it is that you need to do that. I don't think it's it's not a preference thing. It's a utility thing. It's which one do they trust more.
Well, and which ones are possible too, like in a more native code environment where you've got lots of compiler options that vary by architecture or whatever, those two binaries are just not compatible. I can't run them in the same place.
Right.
So you giving me a binary doesn't help me at all. Like, but in
Well, if I can
JavaScript
tell
or
you where
Java.
it'll run, right? Then
Oh,
you
sure, but-
decide
yeah.
whether you can use it.
Yeah, absolutely.
And that's what we're trying to do.
Yeah.
So we've got 5 minutes left, so I'd like to open it up to any questions that people have for the panelists. Okay, on dependency management and package managers. Thomas.
Does the panel think it will be useful if binary repositories like npm.js or Maven Central will universally implement the feature that allows you to basically report the package as being no longer maintained? So I have like user reporting as being this package, do not use this, from a crowdsourcer's perspective. Kind of like,
I think this would be useful, and so the question is whether central packages should have a feature to mark some components as deprecated. And in fact, I would go further and say I would have a dead man switch. So if somebody is pinged whether he or she is still alive to maintain the package and doesn't respond a couple of times, then this package is marked as risky.
So you're proposing a web of distrust.
Yeah, distrust by default. I just need to plug that there is actually an ongoing project that called FOSDEM. Do we have materials?
Yeah, we have some survey questions.
You have some survey questions on your table. And I think it's not just about thinking of deprecation, it's about metadata coding associated with the packages that you're using. So when you pull in dependencies, it is able to tell you that it was a binary breakage, like an API breakage, or there's a security advisory, and deprecation warnings is basically just one other use case there. The idea is to also include compliance information in that, so that when you're building code as a developer, you get warnings if you pull in something that has outstanding CVEs, etc. So I say this is totally useful. We're not the only people who think this way, because this got even funded by the EU, and part of that's being developed.
So my little hobby horse here is to get back to that connection between the binary and the source. Because if you get back to the repo, whether it's on GitHub or wherever, right, if you can go from the binary that you're about to use to the community that produced that binary, you can start understanding much more about, are there thousands of open issues? Are there no developers? When was the last commit? All those sorts of things that might help you make an informed decision. So, more information, yes. I'm a little bit leery of the social aspects of all the random registries running a poll saying this is good or this is bad. That gives me pause, but conceptually, yeah, I think we need to have more information from the crowd, crowdsourced to help people understand what's going on.
Well, I think Tom mentioned this in your talk today that like the trend community or something like that, they have this thing that if people don't update the dependencies, then it automatically gets faded out of the repository.
Yeah. So if you're like a maintainer, you have a package that depends on another package. The package on which you depend gets a new version. As a maintainer, you should. Sorry. As a maintainer, you should then also update your own package. If you don't do it, you don't respond. After I don't know anymore. Like after 2 months or so, you automatically get archived. So your package will no longer be there again. So I understand how that works. If the package is depended on by like a million, do they automatically?
In that case, maybe probably
It could be that the community then takes over to make sure it still works. Okay. The other thing about CRAN though is that like they archive versions of things so often and they update so often that like any checksums that you put in the package manager are likely freaking wrong. And so like there's no way for us to securely fetch from them because they've likely archived the version that we trust. And I don't think that's helpful.
There's legal issues.
Yes.
Are you involved with CRAN at all?
Okay. If you know people, I want to talk.
Well, we're officially at time. So thank you, everyone. Thank you to our panelists.
Thanks, William, for that.